Swayam Prabha. Digital India. Educated India.
So, welcome friends, welcome students. Now we are in the 8th lecture, the 8th week lecture, and this last week we have kept the module on the environmental acoustics. So, in this module, in the 5 segment of those lectures starts from the lecture number 36, which will deal with the environmental acoustics 1. We will go to the environmental acoustics 2 in the next lecture, and then we will go to the some urban noise and some of the dealing with the urban noise and the mitigation of the noise. So, as usual we will start with the learning objectives. So, here we will initially classify the various types of environmental noise, and then we will discuss the effect of the noise and some of the measurement techniques and the measurement indices. Now, the first one is which comes in our mind is that what is a noise? Noise is actually an unwanted sound. It has typical 3 parameters. If the sound is very loud, then it is the unwanted in that way, and sometimes it is the unwanted in sense of this unmusical kind of a sound, which cannot create that kind of a sensation, that kind of interest in our brain or interest in our mind. So, that typical sound will be treated as a noise kind of a thing. So, it is again a very much subjective criteria, but even though if it is a subjective criteria, there are some kind of characteristics in this criteria, where the magnitude of the sound and the duration of the sound and typical frequency of the sound, and also the when its particular sound is actually going to be occur, the time of occurrence is very important to know about that particular, or the judge about that particular sound is a noise or a music. Actually, the opposite word of the noise may be a music, which we can treat as a subjective one always, and the wanted sound or the sound we may prefer to hear can be treated as or defined as a music, and which is not at all wanted or not at all preferred for hearing, or cannot create any kind of interest in our mind or in our brain or in our sensation, is called noise. So, most of the time if you go to a outdoor, or maybe if you walk in the urban area, or maybe a township, or maybe any area where this is exposed to a lot of noise, and if you see that particular character of the noise is actually typically comprises of different frequencies of the sound, and also the varying of decibel levels or so. So, I have drawn here a particular curve, or the sinusoidal curve, which is very much regular in shape and which is very much going to be a periodic in nature, and in another one which I have drawn, which is typically periodic, ups and downs, the fluctuation of the sound, fluctuation of the pressure is also differentiating, which is also a propagation of the sound, but there is a difference between this green color graph and this red color graph. The red color graph is very much scattered or very much unwanted in that sense, and it is very much, you can say, uncertain, then when it will be a peak and when it will be another throat, those kind of a scenario. So, because of this particular second graph is a mixed of a complex tone, and there is absence of the harmonics and the octaves, and it is a very unsteady in character from the amplitude point of view, and as you know, if the amplitude varies, the differential pressure level will be there, or the differential dB level will be there. So, this can be treated as this kind of a spectrum, the sound spectrum can be treated as noise, whereas if it is a complex tone, but it is a more of harmonics and the octave, which gives a kind of a smoother, the repetitive kind of a periodic curve, and a steady character of the particular curve from the amplitude and this particular amplitude and the frequency point of view, it is the music or which is we can want to hear. So, next comes the noise pollution, because noise pollution is very much related to the urban noise, and noise pollution is one of the prime factor nowadays. Every citizen of the country, in our country and also in the other countries, very much bothered about. And what is the noise pollution? It is it's kind of a environmental cause which due to the sound, and that is a kind of a given kind of a threatening to the health of the human also for the animal inhabitants. Because of the not only from the dB level is the one of the criteria, it's a kind of a criteria. It's not only the dB level, but also the particular frequency built in it, and the repetition of that particular frequency is quite unsteady kind of a thing, can create a kind of a noise. Because if I give example, a guitar may give you a music, and if I start playing guitar, sometimes it may be a noise to you, because I do not know how to play a guitar. So, if I play, then it will be different frequency, in unsteady way it will follow, and then that can be a noise that you cannot maybe tolerate for more than a minute or so. So, noise pollution is actually associated with the outdoor scenario, or that is called as a outdoor noise, and that are having different the cause or the different sources. We will discuss in very detail of that. So, out of the causes is the industry, community, construction and the transportation sector is the major source of the noise pollution. Next, let us go to the urban noise. There is not very much significant change between the noise pollution and the urban noise is concerned. The noise pollution is that if you are the particular noise level is above a certain particular limit, which was prescribed by some of the pollution board or so, which is can be act as or can be threatening to the health, and that can be treated as a noise pollution. Whereas, in case of the urban noise, there are some areas which may be a kind of a polite amount kind of a noise, which may not go beyond that particular limit, and sometimes it may go. Sometimes it may go in the night time, sometimes may go in a specific duration of the day. So, that there are a lot of other parameter associated with those activities, the urban activities and all. And due to that particular activities, there are source and there are kind of the environmental noise has been concerned or has been perceived, and that particular the noise which is triggered by some kind of a urban activities are in a bracketed terms, in a domain terms called the urban noise. So, what is our main concern is that in our lecture, in the consecutive lecture of this last module, is that how to investigate effectively investigate that particular noise, and we have to actually know about the sources of the urban noise, and also we need to know the how we have to mitigate those and reduce this particular noise, urban noise. So, in that we have we can have this kind of a flow diagram, and let us know what are the typical the flows and the components of a urban noise mitigation strategies. The first one, we must know of the know about the urban noise source and the impact of the urban noise. This is very much important. Some source may not give any kind of impact, which is impact I am talking about the which is very much threatening to the health of a particular human being or maybe an animal. So, sometimes a particular source may be having a very high impact. So, we need a kind of a noise measurement technique, and that is very important to know between the relation between the source of the noise and the impact of the noise. And then there are some parameters, which parameters are actually influencing the, sometimes it is going to the add, or sometimes it will going to give some kind of advantage towards the propagation of the noise. and sometimes those parameters are actually going to resist this particular noise. So, to know about those parameters and we have to actually design that particular built environment such a way the resistive parameter are potentially increase, and that can be reduce the amount of noise or the urban noise. And based on that only, I have already told, based on those parameter on only this noise reduction strategies can be thought of or can be implemented. Now, as we have to know about the different source of the noise, so let us first talk about some kind of the noise which is called as the different classification of the urban noise, and the first one is the traffic noise. Each one of you are actually exposed to this is a noise which comes from the surface transport, mainly from the road, railway, and maybe some kind of the aircraft movement or so. The second, it has actually 4 typical subdivisions or classifications. Second one is the industrial noise, which comes from the workshop, any kind of industry, plant and all, because of the activity and the operation of those industry. The third one is called the construction noise, which is sometimes very bothering. The noise comes from the construction equipment like hammer, jackhammer and the pile driver, concrete mixture and lot more. And those who are actually stay very close by those construction the activity areas, maybe for years or 2 years or so, it is really sometimes bothering. The fourth and last one in this classification is called the community noise, which is actually a noise generated by a community, which are the street noise from the any gatherings, maybe it is a social gathering or maybe a political gathering, some kind of a rally, or some kind of a the noise from the children, they are playing in a particular park or maybe a school or whatever, and the loudspeaker noise from any particular area, then some kind of something like a barking of a continuous barking of a dog or those kind of things. It is very irritating in the time in the night times if the dog barking for a long duration. So, those are has to also taken care of very carefully. Now, let us go to the first one, that is the traffic or the road traffic noise, and there are different significant the amount of the noise is developed in the road, and it is actually the one of the major source of the noise pollution in any city or any urban area. There are different cause of this. Suppose if you take a automobile, if you take a car, or if you take a lorry, or if you take a kind of a bus. So, there are different noise producing the component in it. There are the exhaust, there are some kind of the engine, fan, and those tires, and also it is depend upon the speed of the particular vehicles also. But it actually depend upon several other factors like what is the road condition. If the road condition is good, definitely the amount of noise created by the traffic or by this vehicle will be less. The congestion of the traffic clearance and all those kind of things are also creating a noise. If there is almost this uniform speed maintaining in a particular patch of road, the amount of noise again will be going down. The sudden braking and all those things actually create the noise, the sound of brakes and all. The condition of the vehicle is another one, the speed of the vehicle is another one, and as you know, the speed of the vehicle, if it is increased, noise is not proportionally, but somewhat it is increased. There are driving rules and monitoring systems are also as a maybe the indirect parameter that influence the urban noise or the urban road traffic noise, and the last one is not the least, it is the common sense of people or the citizen is also one of the important factor which contributes in this domain. And in the case of the railway traffic, there are some the components which comes from a particular source itself, that is the railway itself, that is the diesel exhaust, engine, cooling fan, etc. The wheel rail friction, that is another one which creates some kind of irritating sound, electric motor which actually drive the train, the siren, horn, braking system, everything which is the each one of those are the integral part of any kind of a railway system or the railway motion, which is going to give some kind of a noise. And other than that, the track to observer distance, that is one, track length is another one, the amount of load in a train, particularly for the goods train or the freight train. Suppose a goods train is empty, sometimes it is noisy. If it is not empty, it is full, then may not be noisy. It is sometimes not that, if it is a load is huge, then the noise is more, no, sometimes less. The empty vessel sounds much, we all know. And the other conditions are the some of the condition of the track, and sometimes the condition of the coaches, and everything also impart some kind of a noise, air traffic noise. This is the third component of the transportation noise is concerned. It is actually depends upon the speed of the air traffic and the distance from the observer to the source. By virtue of the traffic, the air traffic and air strip in a particular area, it is depend upon the what is the distance from the source to the observer. And in time of, if it is very near to it, the receiver, the observer is very near to the airport, then it's the taking off and the landing time, the aircraft produces the much noise, and which sometimes unbearable. Yes, supersonic jet planes, if it is a very high distance also, from a very high distance also, its extremely high level of noise will going to produce. Sometimes it may break the window panes, and it may some minor cracks may appear in the very the building walls and all, because of that sonic wave propagations also. Then next comes the industrial noise. We already talked about that, and those are the typical different part of the activity, or the different stage of the industrial activity, which actually produce some kind of the industrial noise, which includes the some running machines, hammering, grinding, some lathe works, the steaming, boiling work also. See, the next one is the construction noise, which again is depend upon lot of construction activities, and as you all know that each and every construction stage requires some kind of a manual or maybe some kind of equipment for operation, and it's not a silent process, it gives you a kind of a noise. And it's actually so, I mean, it is actually the area which is surrounded by those the construction activity is prone to those kind of construction noise, and it's actually the people who are staying in a newly developing or the upcoming area is mostly affected by this construction noise. And those are the list which can create a very annoying kind of a noise in construction activities. The earth moving work, the demolition of some existing structure, driving of the pile is very monotonous in noise point of view. Concrete mixture, pumping of the concrete, that any kind of the welding is probably a kind of a bit of silent process, but the riveting and the next one is the hammering is very bothering, it's from the noise point of view. The last but one, that is the cutting of tiles is another one which is produce a lot of very high frequency sound, and which is a very high level from the dB level point of view, it is very high and also very much affecting, I mean the physiologically or maybe the psychologically it is very much affecting. If you stand for a quite a 1 minute or so, it may not be unbearable sometimes. Then the community noise, it is the part of the community, part of the activity in the community, and due to that this community noise also sometimes our common sense is responsible, yes, and the enforcement authority are may not be very much strict, and they allow people to run the loudspeaker in the very late night or so, which may create a problem to the people like the elderly people with illness, the kids and infant and all. So, those are the some of the activities I have already told you, those are the community noise point of view. And there are some effect of the noise. I told you in the very beginning, the noise pollution has defined as it's something above some kind of a criteria of the dB level criteria, and which gives you a kind of a harmful effect in a particular human health. So, there are three types of human health as per the WHO has stated. There is some kind of a auditory, which is the hearing loss and the threshold of shift kind of a scenario can be happened. There is a psychological, which is a stress, there is a metabolic change, there may be a hormonal change also, there may be some kind of a gastric problem due to the if you are exposed to very longer duration in the noisy atmosphere. There will be a behavioral change if you are prone to a noisy atmosphere very long duration, like maybe a month or more than that. Then there may be a changes in the normal behavioral pattern. Mostly it's have been felt in the wildlife, but also it has been felt in the people who are exposed to the industrial noise and the transportational noise in a longer duration period. Next, the parameters. We have already talked about that there are some parameters which are going to affect this particular propagation of the noise, which is the urban noise. It is the source, geometry and the type is one of the things, that is the point, line, actions, coherent and the inherent kind of a criteria. The meteorological conditions, the wind, temperature, the flow of the wind and the speed of the wind is also going to be a matter. The propagation of that particular noise, the atmospheric absorption of the sound, which is due to maybe some kind of a humidity or some kind of a other suspended matter in this available in the air. The terrain type and the contours, ups and down hilly areas. So, there can be some kind of the noise shielding zone, noise shadow zone, and finally, it is some kind of obstruction. This may be a man-made obstruction, there may be kind of a natural obstruction by the vegetations or so. So, that also can help sometimes propagation. Next one is the measurement of the noise. So, I have just chalked down some of the case specific and also the positioning of the instrument as per the directive of the Central Pollution Control Board, Delhi. This is CPCB. So, they have stated some kind of the criterias. Suppose if you are taking some kind of a sound for any DG set, that is the digital generator set, or maybe any machines, it is 1 meter from the distance from the all the side, and if it is more than that, so about 1 meter distance from the acoustical enclosure, we have to take the measurement for any kind of a firecrackers, which is again one of the concern. Sometimes Supreme Court says some kind of a the rules or the kind of a guidelines for that. So, for that particular measurement of that particular sound, the blasting sound of the firecrackers, it is 4 meter from the blasting point has to be taken, and there should not be any kind of a reflective surface in and around the 15 meter of the radius. That is another criteria. Because if there is a reflective surface, the total amount of sound actually recorded in that particular microphone will be very much high. For any kind of the vehicle, for the road noise measurement, 0.5 meter from the exhaust point of the vehicle has to be taken, which is very near to that particular the exhaust point of the vehicle has to be taken, and the microphone point should be placed at around 1.2 to 1.5 meter, which is almost about 5 feet, 4 to 5 feet level above the ground, which is more or less of our ear level or so. And in case of it has to be taken in the dry condition, because you know that the wind velocity also plays an important role. So, any conditions which should be the wind less than 5 meter per second, velocity should be that should be the criteria of the measurement, and this instrument should be free from any kind of the vibration or any kind of a shock. So, as we know, this particular noise is having a combined frequency and also very much of combined the levels, dB levels. Suppose some source gives you some dB level L1, then some other source gives you L2, L3, like that. So, we cannot judge each one individually. We have to give a one particular the number, which is can be either a total noise level or maybe average noise level. This is the formula to calculate the total noise level. If there are n number of sources, gives you the L1, L2, L3 and Ln. So, those are the L1 by 10 and this 10 to the power that has to be added arithmetically, and that has to be logarithmic of that and has to be multiplied by 10 will be the simple way to find out the L total, the total noise level of a particular the area for a particular instant probably. Actually, this 10 to the power L1 by 10 is nothing but the intensity of a the particular sound in that particular time or that particular source of which is actually producing L1. But there is average noise level also, which just that which I have added in the the other slide, the previous slide. We have to divide this by the total number of sources n. So, suppose this comes from a bus, this one comes from some kind of a some road note for some kind of another source. This is some kind of a shop, maybe it in a stretch of a road. So, there are 3 such sources and then you divide that by 3 and take the logarithmic of that and then multiply by 10. So, this is the average of the noise average, the average noise level of that particular segment of the road for a particular segment of that particular moment on when you are taking for that particular reading. So, I have a small example for you. I have 5 sources, suppose in a roadside, and or maybe it may be a kind of a 5 machines that produce the noise in a particular industry, and the first one gives you 75, the second one 30, 50, 90 and 65 like that. So, this is by 10 is 7.53, then 5, 9 and 6.5 and 10 to the power of that is this, and I have added it up, and number of samples at n is 5. So, if I now want to find out the total, so I have to logarithmic, I have to take up the log of this whole big number and then multiply that by 10, and that gives me almost about the 90 dB is the total noise level. But if I want to find out the average, I have to divide this by 5, then divide this big number by 5, that is the and then I take the logarithmic and then multiply by 10 and I will get little less amount of as an average noise level, L average 83. So, what I find out from here is that the L total is always going to be little higher from the average point of view, but it is not the just actual the half of that or not like that, it is a kind of a little less than the average is little less than the total. Again there is the very one of the very fundamental the criteria which comes in our mind is that the human hearing system is not equally sensitive to all the frequencies, as you all know. So, if I just take that average, or if I take all this weighted this particular total of all the frequencies of all the L1, L2, L3 all the sound pressure level, it may not give you the actual indication of the noise or actual indication of the total noise or the average noise. So, for that a adjustment has been made for different octave band frequencies, and those octave band adjustment finally measured in a I mean this adjustment is called a weighting adjustment. There are B weighting also, C weighting also, but the A weighting adjustment or the measurement are very much very much effective for our noise calculations and environmental noise calculations and all. And how it is can be done, we can just give you a kind of a statement is that there are 10 octave band, and for this octave band this correction is given in dB. So, suppose you have, and these corrections are mostly negative corrections. So, if you have some decibel level for 31.5 corresponding to 31.5 with their upper and lower band, if you remember we have a octave band which is the upper hand and the lower hand, that is the upper and lower band. Within that, if any frequency comes which comes under the 31.5, you have to subtract 39.4 dB from that, because those low frequencies not that much sensible in our brain. Suppose something is within around in and around 2000 frequency, then you have to add 1.2 frequency, whatever may be your recording from the dB meter, you have to add 1.2 decibel. If it is 1000 in and around 1000, you need not to do any kind of a correction. So, mostly you see there are negative corrections and there are only 2 for 2000 and 4000, there are some positive increment. So, if I take another example, suppose I have measured a particular band of frequency in a noise for a particular moment in a particular road or maybe industry or maybe any community, and if I analyze that particular spectrum of the noise, I found 31.5 the hertz sound measures contribute almost about 60 dB, 63 is 55, this 125 hertz sound in and around is 35 dB or so, something like that. All the 10 frequency, 10 octave band frequency, these are given. So, I want to find out the what is the A weighted scale. So, I cannot just take the previous formula and just calculate and that I can find out the total, but that will not be the actual reflection of the noise actually we hear. So, we need some kind of a correction. So, those are the 60s to 40 which is in the given in the this particular slide. I have measured, I have put over in this particular column, second column, this is octave band and these are the correction factors. Red or these purple colors are the negatives and these green colors are the positive. So, if it is 60, so if to 60 minus 39.6 is 20.6, 39 and 55 minus 26.2 is 28.8, something like that. If you take the negative, I mean if you take the subtract from this to that, 75 does not have any correction. So, it will remain as 75, 60 is plus 1.2 to 60, 1.2, 45 is 45 plus 1, 46. So, you get the corrected dB level. So, even a particular sound in a roadside which is having a 31.5 frequency which measures as 60 dB, actual effectively its impact in our brain as per the A weighted scale is 20.6 dB or so. That this corrections means that. And now from that this column I found that Li by 10. So, this is 2.06, 2.88 like that and 10 to the power of that. So, this big numbers and I add up this big number. So, this is a very big number and then this very big number is log, the logarithmic of that very big number in multiplied by 10 is that is the formula for the L total. So, I will write this as a 79, I found it as a 79.6 and when I write it I will not write dB, I will write dBA. Why A? Capital A, because it is A weighted scale. So, any environmental noise is actually weighted in a scale, A weighted scale, and finally, as you know, if I just if I do this logarithmic of the addition for the L total with this second column, which is actual reading, could have been much higher, and there can be a kind of a confusion, there can be a kind of a relative the higher value we will get. So, to avoid that kind of a confusion or avoid that kind of a relatively higher values in our calculations or in our understanding, a weighted scale has been proposed, and finally, we will write that particular unit as a dB decibel A weighted A. So, that is the end of this lecture of lecture number 36, which talks about the environmental acoustics part 1. So, as I have some homework for you like other lectures, let us first differentiate between the music and noise, what you understand from your I mean the understanding of this particular lecture, and from your own understanding on the music and noise, how you can differentiate between these two terms, maybe physically or maybe in case of some objective definition wise or maybe any kind of a subjective way. The second one is also interesting and also very much required to know, I mean what is the actual difference between the total sound intensity level, which is I have wrote at L total and A weighted level, and why these two are required and why what are the significant difference between these two. This is the one, and the second homework for you is that suppose I have 3 noise data, one is 80 dB, one is 50 dB, one is 65 dB. You just find out what is the total noise level and the average noise level because of these 3 sources. If I ask that what is the A weighted noise level for this particular second problem or second assignment or the second homework, it is very vague, because you cannot actually find out. Because why? Because I have to give the corresponding frequency, how much is which frequency contribute 80, which frequency contribute 50 or 65, because based on that, without frequency you cannot go for the A weighted, because if you know the frequency and corresponding the L value, that is the level value, and then you can apply those correction, and then you can go for the adding totaling of that. So, I have taken some help from those books, very good books, and also 2 such I mean the resources. One is this CPWD, I am sorry, CPCB, Central Pollution Control Board. There some documents, which is one of the protocol for the noise monitoring and for the aircraft noise kind of a thing, that also they have given in their website. And also the very new one, this is the National Building Code 2016, volume 2 deals with the acoustics and the noise. This is those are the some the sources I have take help for this particular lecture. You can also go through. That is all for this particular lecture. Thank you very much.